Let's make beautiful tetraamine copper 2 sulfate. We're going to need copper sulfate, household ammonia, and some alcohol. Copper sulfate, tetraamine copper sulfate. The difference between these two molecules was that copper 2 sulfate has 4 water molecules bound to the copper, and tetraamine copper sulfate has 4 ammonia molecules bound to the copper. And this is significant because when the molecule surrounding a transition metal atom changes, it also changes the way it interacts with light. In our case, it's going to alter the color, so it's going to go from light blue in copper sulfate to this dark bluish purple in tetraamine copper sulfate. Now let's get to the main point. So first we have a copper sulfate here. You can see these nice blue crystals. And to that, let's add our ammonia. I'm going to do this in a bottle because even the few drops of ammonia solution makes the whole area reek of ammonia. So let's open it up and pour our ammonia in. Now we have to cap it. Now we shake. You can already see that as the copper sulfate dissolves, the water is turning this dark bluish color because the ammonia is already reacting with the copper sulfate and forming our violet complex. All we have to do now is wait for the copper sulfate to dissolve, and then we can proceed to our next step. It's like 30 seconds in. You can see down here, we have a butt ton of copper hydroxide. And that's kind of to be expected because ammonia is a complexing agent, but it's also a base. So in these solutions, the copper obviously is going to precipitate to some extent as copper hydroxide. So the only real remedy for this right now is just add more ammonia. So if you cap that again, shake, hopefully we can redissolve some of the copper hydroxide so we can then use it as the amine complex. Wait for the copper hydroxide to be taken care of. I've isolated a little bit of the amine solution, and you can see it's this beautiful bluish purple color. Now we have two things left. We have our copper hydroxide waste. You can see a little bit at the bottom there. And we have our proper copper amine solution, which we can just set aside for now. I want to take the opportunity to show you guys an interesting property of the complex. Since I have all this copper hydroxide waste, I figure I may as well use it to show an interesting property of the complex. Here I have some vinegar, and then we're going to add some into the complex. It's only been a few seconds since I added the vinegar, and you can see there's a butt ton of copper hydroxide precipitating out. That's partially because there's already some at the beginning. There's probably some that has to do with the fact that the vinegar destroyed a bunch of the ammonia, and now a lot of the hydroxide that was dissolved by the ammonia can't complex anymore. So now that we have pure tetraamine copper sulfate solution, we now have to precipitate it. So here I have some household alcohol, and I'm just going to pour a little bit of the solution in. It's kind of hard to see, but you can definitely see something has precipitated from the solution. That's our complex right there. After filtering, we're left with this beautiful blue tetraamine copper 2 sulfate. And I get around a gram of the complex. Given that I started with 2 full grams of copper sulfate, this is about a 50% yield, although this should be expected. Let's explore the complex's various properties. Tetraamine copper sulfate is water soluble, and if I add water, it can easily dissolve, forming a blue solution. It's also worth noting, though, that without excess ammonia, a lot of the complex will also decompose to make free ammonia, which is also what happens if you open the cap during storage. Now, this complex is also extremely unstable with respect to acid. Let's add some vinegar and find out. Okay, nothing. Actually, kind of see a little bit. Now by this point, a lot of the complex should be gone and reacted with the vinegar. Again, by adding it directly to the solid. Another run. You can see the copper discoloring and turning light blue again. So now how do you store the chemical? Well, as I've shown, this chemical is sensitive to acids, but it can also decompose if you just leave it next to water or leave the cap open. Because of that, I strongly recommend keeping it in a sealed container with minimal ventilation and far away from heat or acids which can decompose the complex. If you wanted to keep it for a very long time, I suggest putting it in a desiccator and possibly with excess ammonia. I make tetraamine copper 2 sulfate. Thanks for watching. See you next time.